right, hello everybody. Thank you all for joining us for another Usalco webinar. These are going to be for distribution on Apple Podcasts and our Usalco YouTube channel after this airs today, so they're going to be posted there. And our webinar today is about combating Microthrix Parvicella in wastewater. And if you thought you were tuning into a presentation about microchips, we're still glad to have you. I'll begin by introducing myself. My name is Chris Lacey, and I'm located in New Braunfels, Texas, near San Antonio. I've worked in water treatment for 12 years and joined Usalco in 2017 in a technical commercial role. I'm serving now as a technical marketing manager at Usalco, and I've been in this role for about a year and a half. We also have today Brian Leota, who is located in the San Francisco Bay Area. Brian joined Usalco in 2022 and serves as our Director of Marketing and Product Development now. He came to Usalco from Brenntag's North American water treatment business, where he served there for over 20 years. And finally, our speaker today is Kyle Porter, and he's located in Whitefish, Montana. He's worked in water treatment for 10 years and joined Usalco in 2022 in a technical commercial role. And Kyle's now serving as the West Coast sales manager at Usalco, where he's been in that role for about 2 years. So for today's event, please email webinar@usalco.com with any questions or requests. And this deck will be available for you at the end as well. If you need any help finding it, please let us know at that email address. So let's cover our agenda. So today we're going to cover Usalco and go over our company profile. Then we're going to get into Microthrix and Parvicella. We're going to introduce that and some ways to identify the bacteria. And number 3, we're going to cover treatment challenges and proliferation. And then we're going to cover a success story and then walk through the Usalco's coagulant guide and calculations for Microthrix. And then we're going to get into covering some general points on how to feed coagulants in wastewater. And then we're going to touch on bench testing to identify the most optimal product and just kind of some generalities on how to do that. So I'll go ahead and hand this over to Brian now.
Thanks, Chris. Greetings, everyone. Just high-level information about Usalco. Our vision at Usalco is to lead in creating water treatment solutions that not only meet today's needs, but also drive a more sustainable future for future generations. As far as our mission, we truly want to be a force for good in the world, enriching the lives of our stakeholders and communities by addressing America's pressing need for clean and accessible water. Amongst our values, our core values are safety, integrity, customer focus, teamwork, and innovation. And these principles guide us in everything we do. We strive for results and to ensure respect for people in every interaction. As far as our locations and our impact on the world, particularly in North America, we have over 26 plant sites and 7 logistics hubs. We have a nationwide presence, so we're truly coast to coast in the U.S. Our team of more than 500 individuals contribute to positively impacting over 130 million lives and ensuring over 70,000 deliveries annually. As far as the future expansion of our company, we're always on the move, and we're expanding now in Southern California, and we're just demonstrating our ongoing commitment to growth and also serving new regions with advanced technologies not previously available to those regions in an economical manner. As far as the map that you can see on the screen, our diverse locations, we're spread all over the place from coast to coast, as I mentioned, but it includes specialty and conventional plants, rail hubs, warehouses, and labs. And this all highlights our operational capacity, which was organized specifically to meet the water treatment needs across the country. This illustration shows the critical aspects of a typical wastewater facility, and it includes typical aspects of coagulation and filtration, pH control, disinfection, chemical process control, and operating personnel, all essential to providing appropriate water treatment services. So Usalco offers an industry-leading coagulant portfolio and services that improve filter performance, automate coagulant dosage, which is our co-pilot system, and we can provide expert support and training such as the Usalco Coagulant Academy, which is another fantastic program that we launched in 2024. So all of these offerings maximize the facility production, we reduce maintenance and energy costs, we lower sludge disposal and pH control expenses, and minimize carbon emissions, ultimately enhancing the resiliency and efficiency of the entire process. We've got a really great product line. It's comprehensive, as I mentioned before, and it's pretty diverse range of advanced coagulants and polymers, which are tailored to optimize water treatment processes. So you probably recognize all the signature brands at the top of the slide, brands like Delpac and UltraPac, GPac, DeltaFloc, UltraFloc. They all provide specialized solutions for various treatment needs. For iron and aluminum specifically, we manufacture a comprehensive range, including polyaluminum chloride, ferric sulfate, and ferric chloride, all designed to enhance coagulation, reduce sludge, and improve water clarity. Our polymer lines, such as the Polydad Max and EPIs, offer additional tools to support efficient coagulation and liquid solid separation, ensuring optimal performance. Just to add a comment, a general comment about the product line is that the way it's laid out, it's almost infinitely customizable. And what we mean is we take this approach to water treatment and recognize that every water system has unique attributes. And so ours is not a one-size-fits-all approach, and we take a consultative view for each opportunity. And with that, I'm going to turn it back over to Kyle.
Hey, everybody. Well, hey, we can get right down to the topic at hand and get started about talking about Microthrix in particular. Microthrix, or Parvicella, is a type of filamentous bacteria which causes bulking and foam while reducing the plant's biological performance. It can be really, really difficult to eradicate once it gets developing in the plant, but it's a really common issue I think many of you probably have seen, and particularly around seasonal events. So Microthrix in particular and the characteristics around it, it's a low food to microorganism ratio filamentous bacteria. That means generally you have more bugs than you have the BOD or food source for it. Thus, it's often going to appear in plants too with a long sludge age where you've been basically wasting, or let's say wasting, returning a lot, right, to get more processing in your process. In particular, though, it also really, really likes long chain fatty acids. So if you're a plant that's going to be having, a high percent of stuff coming in from even something just like restaurants, if that's a high percent of fog coming in there, but also if you have dairies, meat processors, any industrial process with a lot of fog and stuff coming out, you're likely going to have a higher chance of having this type of issue. And then kind of mentioned as I did in the last slide, it really tends to form during seasonal weather changes. You're going to see it a lot in the spring, and that's part of the reason why we're doing this call when we're doing it. It's January right now, and I think you're most likely to see it probably in February and March. So traditionally with it, most plants have kind of just responded to Microthrix by hitting it with oxidizers. And I think most folks have done that. And even for different filamentous bacteria that aren't necessarily Microthrix, that's kind of always the catch-all, right? Is you throw some bleach in there, you throw some, you basically throw some, HDH powder in there, right, with chlorine, try to hit it. But I think as many of you guys have also probably realized, it's not really that effective more often than not. It may work, but it's also going to kind of kill everything else while it's at it. On top of that, you may not always get a full kill, of the Microthrix or a full removal. But again, in general, it may work, but it's also going to have a lot of other negative consequences on your plant, the biology, and your ability to meet performance. Like I said, you'll see many of the telltale signs when you see that kind of bulking and foam on the top, and you'll really, really have poor sludge settling. Again, it can happen, and the main thing you'll see at the end too is you'll have a very turbid effluent at that point, and it doesn't really matter how much coagulant or anything you throw at it there initially, it's going to seem like it's not making a difference. So as I stated, kind of why it's proliferating or why you're seeing it, it's really kind of a low food to microorganism ratio bacteria. And by that, I mean, you're going to need more BOD and COD. Really what's happening is it's taking up those fat lipids from the different COD and fog you have, and that's its food source. And of course, you're going to see it in your biological sections of the plant. So as again, what's going on with this is that you're going to see those oxidizers that could kill potentially your good bugs. Some of the other things you can do is you could try to lower your mixed liquor suspended solids sometimes in your sludge age, but again, you're going to limit your ability of your plant to fully reach its kind of phosphorus, nitrogen, and BOD potential. I'd say long term with it, you're really going to want to improve that food to microorganism ratio, and really that's usually done by adding methanol or some kind of glycerin or different carbon source. But one other option we have here too, of course, is our polyaluminum chlorides, and one of the things I think is so great about it, and they're a little more elegant and multi-purposed, you're going to use a coagulant anyways, obviously to achieve good settling and get good phosphorus removal. But what's really nice about the coagulant is that I kind of reference back to those fat lipids. The coagulant works by preventing the uptake of those fat lipids for the Microthrix and starves them out. It's been found basically with these lower basicity packs that they have that benefit while also giving you the same side benefit of being excellent at phosphorus removal and improving your settling. So you kind of kill two birds with one stone. So kind of on that topic, we wanted to go to a quick success story, from this to cover. And this is a plant that's been able to avoid the formation of Microthrix that, previously had quite a bit of it in the past. So it was, it was and still is, a 7.5 million gallon per day plant. They had traditionally gotten some Microthrix basically every spring or so when the weather came up, and they had just been treating it by hitting it with chlorine and kind of finding minimal success. So, again, it was a bit of a seasonal thing for them. In an effort to kind of avoid those different Microthrix flares, what we had them do is we trialed some Delpac 1842 with them. And of course, we dialed it in to hit their different treatment goals for phosphorus, BOD, et cetera. But we also did it in a way to help them prevent Microthrix. The plant started out initially feeding about 212 gallons per day for 5 weeks. And it's kind of the introduction build-up start dose. And then from that, after that, they lowered it down to about 35 gallons ongoing. And that's been the level they needed based on jar testing to hit their phosphorus performance. They're settling, and they've not had any issues since. So, it's a success story until it's not, but for now, we can still count it. It's been quite a while. It's been a few years. And the good part about this I mentioned is while we can jar test for the phosphorus and the other side there for your, I'll say, ongoing treatment, there's not really a way to jar test the Microthrix when you're having an outbreak. And that's generally when people are calling you, right? And whenever you're having that issue. It's not something that is killing it, right? Per se, it's something that's going to take some time to prevent the fat lipid uptake. So it's something that you can't see immediate results with in a jar test. So thankfully for that, we were able to come up with a coagulant dosing guide for this, and I've got it here pulled up on the screen. But at this part here, I'm going to hand this back over to Chris and go from there.
All right, thanks, Cal. So for this guide that we're going to cover, that can be found on our website under resources and under the tech resources tab. It's very easy to find it. And we have this Microthrix resource along with some others. So let's get into the purpose of coagulant optimization. And, the purpose is to discover the most efficient coagulant for that particular application. And there are 3 components. So we begin with optimal metal salt. Is it iron? Is it aluminum? We need to determine which metal salt is going to be the best for this particular application. And then we get into, need to find the product that maximizes the concentration of metal per part. And then we get into finding the best performing basicity for that water. And that occurs when bench testing's performed. And the combination of these 3 is where the most optimal product is at and where it's going to be. And if you're wondering how does price factor in, that's why maximizing the metal content is a key component. Freight, packaging are typically a major cost component, and this serves to minimize that portion of the cost. All right, so let's discuss the coagulant guide. These are Usalco's standard recommendations for remediating and preventing Microthrix. And the key differences between them are the AL or aluminum for these 4 products. And then the most important for overall performance is the basicity of the products. And they're going to vary from product to product, as Kyle mentioned, from low basicity to the medium basicity packs. So for remediation, we need to calculate the aluminum dose per kilogram of mixed liquor suspended solids. And so we're going to go through these steps here, step A through E. And let's go ahead and get into step A. So we want to calculate the aluminum dose per kilogram of mixed liquor suspended solids by taking 60 and dividing that by the sludge retention time. And so for this example, let's go back up to the top so it's crystal clear. The mixed liquor suspended solids for this example is 3,000. The sludge retention time in days is 25. And then the coagulant chosen was Delpac 1842. So like I said, we're going to calculate that aluminum dose per kilogram first. And then we get to step B, where we convert the milligrams per liter of the mixed liquor suspended solids to the kilograms per cubic meter for the example, which we have is at 3,000. And we then divide that by 1,000, the factor of 1,000, which then equals 3. So we get into step C, determine the dose of aluminum per cubic meter of mixed liquor, which is taking the result from A and multiplying that by the result from B. So 2.4 times 3 would be 7.2 grams per cubic meter of aluminum required for that particular mixed liquor solution. And then in step D, we take Delpac 1842 at the aluminum of 9.01%. We just need to convert that to a decimal. So real simple math, convert it to a decimal and get 0.0901. And then finally for step E, we calculate the dose of aluminum required by dividing the fraction of aluminum in the coagulant by 7.2 divided by 0.0901, which we then results in our 7.9 parts of Delpac 1842. And then we get into the prevention slide and the prevention dose. And so for this, it's a very simple factor. And we found that 6 is a very good rough factor estimate for the prevention dose. It's going to vary by plant. So it may be a little bit lower, maybe a little higher, but it's usually dividing by 6. And for this example, it was 13.3 parts. So I'm going to go ahead and hand back over to Kyle now.
Got to get myself unmuted. Lastly, here at the end, we'll just cover a bit about the wastewater process in general and the point of application, being that that's pretty key to it. Again, it's logical this too, considering the Microthrix is a low FM, filamentous bacteria. You don't really want to put too much of the coagulant right at your primaries up front because you don't want to take all the BOD out of your process. At this point, you're already in an environment where you're generally deficient in BOD relative to the amount of microorganisms or what you're looking to process. So in this case, we always recommend from a cost standpoint as well, you're going to want to usually put your coagulant as late as you can in your process. And, every wastewater plant's about, it's very different, right, in terms of laid out, but generally after your aerobic section, your aeration basins, if you have a secondary clarifier, that's optimal. But generally as late as you can be, or somewhere you're going to get a decent amount of shear and mixing in time. But you don't want to put it earlier on because you're going to end up using the coagulant on a whole bunch of things your biology can do the work for you free, and cheaper. But again, if you're at the point 2, you're finding you don't have a lot of contact time, or let's say you're in something like an SBR where it's kind of all in one box, you throw it in the react phase, but it's not the end of the world if you have to even put it at the headworks. It's just not necessarily always as cost efficient. But that's true, by the way, too, of course, of any coagulant, not just just for the sake of Microthrix. That's true of anything, PAC, alum, you name it. One quick thing to touch on too in this slide is it's just kind of mirroring and showing the details from before, but the important thing here is you're going to want to put that coagulant somewhere you're going to get good mixing and shear because you want to get good flock formation. This side more or less exemplifies our flock formation. And, if you were able to catch our earlier webinar by Chris Tassone, my counterpart, about phosphorus removal, this is pretty key to the process and very relevant as well for anyone who's doing wastewater treatment. But again, it's really all about having good flock, basically having good initial shear, particularly to flash it. So again, if you have some questions about that or anything, talk to one of our reps or our distributor folks, and they'll come out and help you and troubleshoot. Slide at a time. And then lastly here, kind of with your water quality goals, of course, you're looking to get better settling. And the whole idea here is that allows you to run as high of a mixed liquor as possible so you can get optimal performance, for your BNR treatment. And of course, having better BNR will let you get better nitrification and better phosphorus removal. And of course, as I mentioned, long-term, the good thing about the polyaluminum chlorides in particular for this is that we can prevent your filamentous bacteria and also give you a product that's as cost efficient and effective as possible for phosphorus removal. You're still going to want to end up adding probably likely some more food, right, to prevent that situation and get more optimal basic balance for your biology as well. But the good thing is we're basically giving you a comfort blanket knowing that we'll help prevent that formation even if it ends up being a little low, food relative to microorganism in certain times of the year. The other thing to really add with this too, in particular with our products is, again, we make everything. We make alum, make ferric chloride, ferric sulfate, PAC, you name it. One nice thing in particular about these PACs though is they generally are much, much lower in terms of their alkalinity demand. And that's particularly relevant for you guys in wastewater since obviously alkalinity is one of the core things you need to achieve proper nitrification, about 7 parts per 300 BOD per 5 parts ammonia. So if we can use something like that pack, which has almost half, if not a third, of the pH and alkalinity demand as your ferric or alum, that's going to give you much better results, and that you're going to need less caustic or lime, et cetera, to resupplement your plant for proper nitrification. And then lastly with this, so jar testing, it's a critical thing for wastewater. It doesn't necessarily, once things are on and you're having a Microthrix breakout, it's not necessarily going to be able to show you that model. That's what the guide is for, right? We're out there. But the important part to think about this is you're really wanting this either way to do your ongoing planning and control. And this is going to be how you dial in your dose, basically for optimal phosphorus removal. The nice part about it is that same dose of this generally is also going to be that minimum you need anyways, or at least still be above that, in order to prevent the Microthrix from forming in the first place. So you're kind of killing 2 birds with 1 stone once again. And as I stated, if we try to cover jar testing, that's kind of a whole nother presentation in itself. We don't have time for that in the scope of this today. But the good news is we don't have to learn that all today. We have a number of our own reps all across the country, some folks under myself out west, and then many others out east. And on top of that, we also have a number of distribution partners. So please contact your distributor, or again, if you need to write into our website, we can contact you with them, one of our reps. But we're happy to come out with you guys, and we'll dial a plant, jar test in, even right down to your specific plant. Yeah.
Thanks, Kyle. At this point, we have an opportunity to open up the floor for questions. And for those of you who took us up on that offer and emailed your questions to webinar@usalco.com, we've got a handful of questions here that rolled in. Okay, I'll just start from the top here in the order that they came in. First question, guys. Is there a way to jar test specifically for Microthrix?
I can, just like Kyle mentioned, not specifically for Microthrix. I think he just said it, or if he did said it earlier, not specifically for Microthrix, but you can jar test for phosphorus removal. And once you determine the correct product for phosphorus removal, that will correlate to Microthrix very well from what we found. That was a good question.
Anything to add, Kyle?
No, I think that covers it. I mean, the key just being, we can calculate the minimum dose, for maintenance for Microthrix with that sheet. And then once they also figure out their phosphorus demand, for the coagulant, it's likely going to be higher. So you'll end up getting the benefits of both.
Great. Next question. This is an easy one. Can I get a copy of this presentation?
Of course, send an email to the webinar at usalco.com email address, and we can send that right over to you. We're also going to post it on our website, and it'll be linked off of our YouTube channel and LinkedIn as well.
Okay. Next question. What type of storage or piping is required for coagulants? That's probably a webinar in itself, but go ahead.
Right. We actually have some awesome storage and handling guides that were put together, and we have them for most of our core products, and they are also located on our website under resources. So if you go to usalco.com, select resources, and under that tab, there's a subsection of storage and handling, and in there you can get a lot of that information. And then if you have a product that's not covered within that, just reach out to us, and we can help you with that.
Thanks, Chris. Next question. Let's see here. It's a typo, but okay, I see what they're saying. Will ferric chloride work as well for treating Microthrix?
No, I'll take this one. Yeah, but no, ferric chlorides won't work for Microthrix control. Yeah, and even basic alum and stuff won't as well. It has to be one of these particular kind of products that are a low to medium basicity pack to prevent that fat lipid uptake.
Anything to add to that, Chris?
I'd say the same thing. It's good.
Okay, fair enough. And then let's see, the last question that I see here so far is, how long will it take to see results?
Okay, yeah, I'll take that. So often you'll see it pretty quickly in, I'd say 5, 10 days, but more often than not, the easier way to think of these things is it usually takes a sledge age. And I know when you're hitting it with that initial dose, right, when you're kind of in it, it can sometimes be much faster because you're hitting it with a really, really strong, quick, basically overshot. But worst case scenario, you should see it within a sledge age.
Okay. Okay, I think that concludes the questions that have rolled in. But just to recap, if you want a copy of the deck that we used today, please send that request to us at webinar@usalco.com, and we'll send it right out. Additionally, we're going to have this posted on YouTube probably in the next couple of days. I think we're going to put it on LinkedIn too. Is that right, Chris?
Yes, sir. Yep.
Great, great. Otherwise, I think that concludes our presentation today. I'm going to throw the mic back to Mr. Lacey so he can wrap us up.
Thank you all so much for joining us. And we also have a podcast channel now that's relatively new, and feel free to subscribe to that. It only has a couple things so far, but we're going to keep adding more and more to it. So we really appreciate y'all tuning in today. Thank you.
Now, Chris, before everybody splits, how would they find that podcast? What's it called?
It's under it's Max Zeta, and I believe if you type Usalco, it should come up in the search. But if you type Max Zeta, Zeta, and Usalco, you should find it very easily under the podcast app if you have an iPhone. And then if you don't have an iPhone, track down the Apple Podcast webpage, and I think you can find it there as well pretty easily.
That's great. Well, thanks everybody for attending, and we'll keep you posted on the next webinar that we're going to launch probably next quarter. Thanks, everyone.
Thank you all.